Good morning, students. So today we are going to discuss a few miscellaneous sum and a summary of the full circle. Since our circle chapter is completed, there are few important sums that we need to discuss, and they are miscellaneous sums. So in summary, the full chapter is summarized into 16 points. The first 8 points are: a circle is a collection of all the points in a plane which are equidistant from a fixed point in the plane. That is the definition of the circle. Equal chords of a circle subtend equal angle at the center. This is one of our theorems. If the angles subtended by two chords of a circle at the center are equal, then the chords are equal. The perpendicular from the center of a circle to a chord bisects the chord. The line drawn through the center of a circle bisects the chord and is perpendicular to the chord. There is one and only one circle passes through three non-collinear points. Each chord of a circle or a congruent circle are equidistant from the center. Chords equidistant from the center of a circle are equal. So first point is the definition of the circle, and rest are the theorems of this chapter that we have come across. Then the next slide is of the last 8 summaries or important points that we need to know about this chapter circle. If two arcs of a circle are congruent, then their corresponding chords are equal, and conversely, if the chords of a circle are equal, then corresponding arcs are congruent. So if we have congruent circles, then their arcs are congruent or equal. If we have equal arcs, then the corresponding circle is congruent. Congruent arcs of a circle subtend equal angle at the center. The angle subtended by an arc at the center is double the angle subtended by that arc or by it at any point remaining on the remaining part of the circle. Angles in the same segment of a circle are equal. Angles in the semicircle is right angle. If a line segment joining two points subtends equal angle at two other points lying on the same side of the line containing the line segment, the 4 points lie on a circle, that is concyclic circles. The sum of either pair of opposite angle of a cyclic quadrilateral is 180. The sum of a pair of opposite angles in a quadrilateral is 180 degree, then the quadrilateral is cyclic. So in this slide, whatever we have gone through are the theorems and few important to remember points that we need to know. So now we come to the miscellaneous part, and we have discussed all the theorems and the important points that we need to know in circles. Today we are going to discuss 3 miscellaneous sums which are important and a little bit different from what sums we have done so this far. So the first sum is two chords AB and CD of the length 5 and 11 centimeter respectively of a circle are parallel to each other and are opposite side of the center. So if we have a circle, then AB and CD lies on the opposite side of the center O. So one is AB is 5 and CD is 11. The distance between this line is given, this two parallel line is given, that is 6 centimeter. We need to find the radius of the circle. So this is the diagram that is possibly going to come out from this question. So the diagram is like this, the one drawn in red. So let O be the center of the circle and R be the radius. We have drawn a perpendicular OM perpendicular to AB and OL perpendicular to CD. So we know a line coming from the center bisects the chord. So AM can be written as half of AB, that is 5 by 2 centimeter, and CL can be written as half of CD, which is 11 by 2 centimeter. And AB and CD are parallel to each other. It follows OML are a collinear points, that is they lie on the same line, and the length LM is given as 6. So let us assume that OL is x, then OM will be 6 minus x centimeter. We have to join OA and OC to find the radius. Since OA and OC are the radius of the circle, so we will get OA and OC. We are going to join these 2 points. Let this lines OA and AC be R respectively, as they are the radius, so we have denoted it with R. Now we got 2 right angle triangles. One is OMA, other one is OLC. So in this 2 right angle triangle, we are going to apply Pythagoras theorem. So on OMA, we will get OA square is equals to OM square plus AM square, which will give us R square is equals to 6 minus x whole square plus 5 by 2 whole square. In triangle OLC, we will get OC square plus OL square plus CL square, which will provide us with R square is equals to x square plus 11 by 2 whole square. So, since both the triangle have R square as their hypotenuse, so we are equating them out together and we will get the equation like this. Now, first term 6 minus x whole square can be splitted, or with the help of the identity a minus b whole square, we can write 36 plus x square minus 12x, and 5 by 2 is a single number, so 5 by 2 whole square is 25 by 4. X square plus 121 by 4. On solving it, we will get x is equals to 1. So the distance OL is 1 and OM is 5. Now we need to find the radius, that is R. So in either of the equation, either equation 1 or equation 2, if we substitute the value of x, we will get the value of R. So here we are substituting the value of x is equals to 1 in the triangle OMA. So we get R square is equals to 5 whole square plus 5 by 2 whole square, that is 25 plus 25 by 4, which will give us R square is equals to 125 by 4. So on removing the square root, we will get 5 root 5 by 2. So the radius of the circle is 5 root 5 by 2. So this is one kind of sum where the chords are at 2 different sides of the circles, side of the center, and we need to find the radius. What if the chords are on the same side? Then what we will find? So here is a question. It says the length of 2 parallel chords of a circle are 6 and 8 centimeter. If the smaller chord is at a distance 4 centimeter from the center, what is the distance of the other chord from the center? So if we have a circle, if this is 6, the 8 centimeter will be just above, since they are in parallel. Since here it is not mentioned that the 2 chords are on the either side of the center, so we can consider that the 2 chords are on the same side of the center. So the smaller the chord is at a distance 4, and we need to find the distance of the chord from the bigger. So 4 is the smaller one. We need to find this part of the chord, the length of the chord from the center for the bigger chord. So here we have PQ and RS are the two chords with center at O. PQ is 8 and RS is 6. We will draw a perpendicular bisector OL on RS and OM on PQ. Since PQ and RS are parallel to each other, so OM is also a perpendicular on PQ. So it is given in the question that OL is 4, RL will be half of RS. Since OL is a line coming from the center, it bisects the chord, so we will get RL as 3 centimeter. Similarly, PM is also half of PQ as OM comes from the center. So PQ was 8, PM will be 4. Now we are getting a right angle triangle ORL. Here RL is 3, OL is 4, so we can easily find OR, which is the radius, and OR will be equal to OP since both are the radius of the circle. So here OR is equals to, we will write our 3 square plus 4 square, that is 9 plus 16, which is OR square is equals to 25. So OR will be 5. Now the radius of the circle is one circle, there exists only one circle, so the radii will be same. So OR is equals to OP, so OP is also 5. Now we will consider OPM, where OP is 5 centimeter and PM is 4 centimeter. We can, by using Pythagoras theorem, we can easily find OM. So subjecting OM, we can write OM square is equals to OP square minus PM square. So OM square is equals to 5 square minus 4 square, that is 9. OM is equals to root over 9, that is 3. So OM is 3. The longer chord, which is of the length 8 centimeter, is at a distance of 3 centimeter from the circle. So this is another kind of sum that we have discussed. Now we will discuss a sum which revolves around a concept of circumcircle. So here is the question. The bisector of an angle ABC of a triangle ABC intersects its circumcircle at the center at EF and DEF respectively. So first we have a triangle. This triangle is at circumcenter. That means the circle is surrounding the circle. Now the bisector of angle A is at D, the bisector of angle B is at E, and the bisector of angle FC is at F. If we join these lines E, D and F, we get another circle, another triangle, which is also inside the circle. So DEF is also a circumcircle. We need to find the angles of D, E and F, or rather here we have to prove the angle at D is 90 degree minus A by 2, the angle at E is 90 degree minus angle B by 2, and the angle F is 90 degree minus angle C by 2. So the diagram will be like this. So here is the diagram. Here A is over here, B is here and C is here. The line that bisects angle A meet at D, the line which bisects angle B is at E, and the line which bisects angle C is at F. Now I have already shown you the triangle ABC and how it's forming the circle triangle DEF. We have to join the lines DE, EF and FD. This is our construction part. Now if we see this angle 5 is this angle 5, and if we know that angle in the same segments are equal. So if we consider this segment, then angle 5 and angle C by 2 are in the same segment. The angle is bisected, angle C is bisected. So angle 5 is equals to C by 2 if we consider the segment BE. If we consider the segment if we consider the angle 6, then it is equals to B by 2, which is at the segment F to C. So here the angles depends upon the segment which we are considering. For angle 5, we have considered the segment B to E. For angle 6, we are considering the segment F to C. For angle 1, which is on top, we are considering the segment F to C. For angle 2, we are considering the segment A to D. For angle 4, which is in our right hand side here, we are considering the segment B to E, and for angle 3, we are considering the segment A to D. So depending on the segments, we are considering the angles. Now for equation 1, if we add 5 and 6, we will get angle D. So let's add 5 and 6. So on adding the right hand side, we have to on adding the left hand side, we have to add the right hand side as well. So angle C by 2 plus angle B by 2 is equals to angle D, since angle D is angle 5 plus 6. In the triangle ABC, by angle sum property A is P, we can write angle A plus B plus angle C is equals to 180. So angle B plus C is equals to 180 by 2, which implies angle B plus angle C by 2 is equals to 90 degree by angle A by 2. If we go on to the next slide, see, angle B by 2 plus angle C by 2 is 90 minus A by 2, as the previous line was angle B plus angle C is equals to 180 degree minus angle A. So on dividing it by 2, we get this, and this part is nothing but angle D. So we will get angle D is equals to 90 degree minus angle A by 2. Similarly, if we add equation 2, then we will get angle E is equals to 90 minus angle B by 2. And if we add equation 3, then we will get angle F is equals to 90 minus angle C by 2. So since the procedure is same, if we can prove for one part of the sum, the rest will follow the same argument. So these are the 3 miscellaneous sums that we have discussed today. I hope this tutorial is helpful for you. Thank you.